All right, this is going to be a video over section 7.4. The intent right now is to break this into two different videos, one for the double angle identities and another video for the half angle identities. So I already have the double angle identities filled in. If I were you, I would just pause the video and go ahead and write those down. Notice that there are three different ones for cosine double angle. And basically, if you can think about this like the following, cosine of a double angle is the same thing as the cosine of a plus a, because a plus a is the same thing as 2a. And then at this point, I could use the sum and difference identities that we did in the last section. So that is how I got the first double angle identity for cosine. But then what happened was I used Pythagorean identities. So for this one, I just plugged in 1 minus cosine squared of a into that for the Pythagorean identity, and I simplified to be able to get this one. Same thing for the second one over here. I just plugged in 1 minus sine squared for cosine squared using the Pythagorean identity, and I simplified. So that will kind of give you an idea of how I got what I got. So let's go ahead, have these handy. We're going to use them, and we're going to learn how to use double angles. So for this first example, I've given you a little bit of a tip list here. You want to use your given information to draw the picture first. So you'll notice that you have cosine is negative and sine is positive. That's what leads me to say that my triangle is going to be in quadrant 2. Once it's in quadrant 2, then I'll use opposite over hypotenuse to put my numbers in for the sine value there. And then I'll use the Pythagorean theorem. And once I find the Pythagorean theorem, I'll find that the missing side is 15, but it's going to be negative because it's going to the left. Once I have that, then let's go to tip number 2. You want to hide your picture and write the identity. So don't pay any attention to your picture for right now. Just simply write the identity down. And so my identity for sine double angle is going to be 2 sine theta cosine theta. And then tip number 3, after you have the identity written down, then use the picture to fill the identity in. So now I'll use both the picture and the identity. So I'm going to keep a hold of the 2, and then my sine of my picture is 8 over 17. My cosine of my picture is negative 15 over 17. And then we'll do the math on that, and I'll get negative 240 over 289. So let's do the exact same thing for cosine double angle. The picture's already drawn, so I'll hide the picture. Let's go ahead and write the identity. You could choose any one of the 3 identities that you have for cosine double angle. I just so happen to use the original one. Once I have that, I can use my picture to plug in. On this one, don't forget that you are squaring. So when you find the cosine value, make sure you square it. When you find the sine value, square it. And then, so I'll use the order of operations. I'll do my squaring first, and then I'll subtract my fractions to get 161 over 289. Tangent will be the same way. Notice that I already have the identity written down there for you. And so we'll use the identity and we'll use the picture. And let me move the picture down a little lower just so that we can see it easier. So my tangent of my picture is going to be negative 8 over 15, and I'm going to use that 2 different times, once on top and once on bottom. So we'll just do the math on that, and I'll get negative 240 over 161. All right, now let's go ahead and jump into example number 2. So for example number 2, let's take a look at what it's asking. Find the values of the 6 trig functions of theta, given that the cosine of the double angle is negative 12/13, and my angle is in the 3rd quadrant between 180 and 270. So the first thing I'm going to do is I'm going to write my identity for cosine double angle. All right, whichever one you want to choose is fine. On this one, I would suggest using one of the identities that only has one trig function in it. So either the 2 cosine squared minus 1 or the 1 minus 2 sine squared. It just gets a little bit trickier if you use both the sine squared and the cosine squared. Well, once I have the identity written down, I can take this statement And in for cosine double angle, I can substitute negative 12/13. And now it's just simply a solve the equation question. So I subtracted 1 on both sides. Got negative 25/13. Just get a common denominator there. And then I'm going to divide on both sides by negative 2, or what I like to do on this is multiply on both sides by negative 1/2. And then I'll take the square root of both sides. Don't forget that it's a plus or minus. Okay. Now, the next thing is why do we choose only the negative value? Because remember that we were told that theta is in the third quadrant, and sine values in the third quadrant are negative. So I'm not going to keep the positive version because it doesn't match the restriction. Well, now that I know that I have a third quadrant angle and I know what the sine value is in that third quadrant, I'm going to use this to draw my picture. Now, this is not my answer for sine. It's just going to help me to draw my picture. So I'll draw my picture in the third quadrant, and I'll use opposite over hypotenuse. When I do the Pythagorean theorem, I'm going to be left with a 1, but it's got to be negative because it's going to the left. And now I have enough information to get my 6 trig functions. And so my sine value is going to be negative 5 root 26 over 26, rationalizing the denominator there. You can use this value or you can use your picture, either one. For my cosine, that's going to be negative root 26 over 26. Again, I've already rationalized. For the tangent, that's going to be 5, negative 5 over negative 1. And then I'm going to go ahead and just uncover the last 3. You guys know how to do the math from this point on to get those last 3. All right, now let's talk about just simplifying or solving a trig equation. So this first one, I'm not solving anything, I'm just simplifying. So what I want you to do is have your identities out, have those double angle identities out. And I'd like to ask, does this statement look anything like one of your trig identities? Well, sure. It looks like the one that says cosine double angle is equal to 2 cosine squared of a minus 1. It looks a whole lot like this side. The only difference is that instead of having an angle A, I now have an angle that's 5x. So what I'm going to do is I'm going to substitute the other side in for this equation. And again, instead of writing an A, I'm going to write a 5x on this one. And then 2 times 5x is the same thing as 10x. Since I don't know where x is or what x is, there's nothing I can do. So this is as simplified as it's going to get. All right, look at letter B. This one also, look at your identities. See if there's an identity that matches this one. And there isn't, but there's one that's really close. There's the one that says sine double angle is equal to 2 sine A cosine A. So this one looks really similar to that, only I'm missing a 2 somehow. So what I'm going to do is I'm going to just go ahead and copy what's already there. And out in front, I'm going to multiply by a half times 2. Well, the value of that is just multiplying by 1. So I haven't messed up the value of what I was given originally. But now this piece looks like my sine double angle identity. So in for what's boxed right now, I'm going to plug in sine double angle. The difference is that instead of using an A, I'm going to use a 165. The 1/2 just gets carried down. And then we'll do the math. 2 times 165 is going to be 330. So we look for the sine of 330. This is in the fourth quadrant, the second to last spoke of the fourth quadrant. And so my sine value there is a -1/2. Multiply those two together, and you're going to get a -1/4.